Hello guys, morning, and I'm here with you to try and use the equations of an inductor. Let me say equations for voltage, current, power, and energy in an inductor. So I've selected this particular equation so that we can try and go through those particular concepts and equations together. So this is it, and the equation states that, as you can see, the equation has a 4 millihenry inductor. There's a galvanometer showing the direction of the flow of current. Then you've been told that Ig with respect to t is equals to 0 at t is less than 0. That's when the switch is open. So as you all know that when the switch is open, there's no current flowing through the circuit. Then Ig with respect to t is equals to 8 exponential negative 300t minus 8 exponential negative 1200t amperes at t is greater or equals to 0. That's immediately when the switch is closed. So the equations given are: find a v with respect to t where t tends to 0, instance of time greater than 0 when the voltage v passes through 0. C, the expression for the power delivered to the inductor, the instance when power delivered to the inductor is maximum, the maximum power, the instance of time when the stored energy is maximum, the maximum energy stored in the inductor. So let's start by finding V, then find V, the value of V with respect to t as t tends to 0. So V, as you all know, in an inductor setup, V is equals to L di all over dt, where L you've been given to be 4 times 10 raised to the power of negative 3, then multiplied by the derivatives or differential. We differentiate the equation of I, where we were given 8 exponential negative 300t minus 8 exponential negative 1200t. When we differentiate that particular equation, we will be having negative 2400 exponential negative 300t plus 9600 exponential negative 1200t, close the bracket. When we multiply, we'll be having 38.4 exponential negative 1200t minus 9.6 exponential negative 300t. So this is the equation of V. But now we have been told that find V as a t tends to 0. So in this particular equation, where there is t, we replace it by 0. So when we replace, the final value of t as it tends to 0 will be 38.4 minus 9.6, which is equals to 28.8 volts. So this is the final answer as 28.8 volts. So that's the final answer. Then coming to the next question. The next question, we've been told that instance of time greater than 0 when the voltage V passes through 0. So automatically through the equation, you can see that the equation of V should be equated to 0, because we've been told that when the voltage V passes through 0. So let's equate the equation of V with 0, whereby 0 is equals to 38.4 exponential negative 1200t minus 9.6 exponential negative 300t. Upon equating, we'll be having 38.4 exponential negative 1200t, which is equals to 9.6 exponential negative 300t. Then divide both sides by 9.6 exponential negative 1200t, exponential 9.6, sorry, exponential negative 1200t. We'll be having 4 is equals to exponential 900t. using the logarithmic concept, that's ln. So it will be ln of 4 is equals to 900t. T is equals to 1.54 milliseconds. So this is the final answer, the instance of time when t is equals to 0. So this is it. Then the next question, we've been told that the expression, checking on this, we've been told that if at all you are not able to see that, the expression for the power delivered to the inductor. So we need the expression for the power delivered to the inductor, and we know that power is equals to VI. So we will multiply V, the expression of V, and the expression of current I. Multiplying, we'll be having 38.4 exponential negative 1200t minus 9.6 exponential negative 300t. Then again we'll be having 8 exponential negative 300t minus 8 exponential negative 1200t. Just then continuing, on continuation, when we multiply this, we'll be having 307.2 exponential negative 1500t minus 76.8 exponential negative 600t minus 307.2 exponential negative 2400t, then plus 76.8 exponential negative 1500t. We can see that there are similar exponentials of negative 1500t, so we'll add them, and the final expression of power will be 384 exponential negative 1500t minus 76.8 exponential negative 600t minus 307.2 exponential negative 2400t. All of that particular expression is in watts. Then, so that's the final expression of power, and here we were told that the expression for the power delivered to the inductor. So this is the final expression. So this is the final expression of power delivered to the inductor. So the next question, question D, the instance when power delivered to the inductor is maximum. Instance when power delivered to the inductor is maximum. So when power is maximum, then we will say that D, the derivative of power, that's P with respect to T all over dt, is always 0. So when power is maximum, then its derivative is 0. So upon that, we must find the derivative of power, and that one, finding that by checking through this, we will have the derivative of power to be this by this will be negative 57 60 100, that's exponential negative 1500t, then plus this by this will be positive, then 46 080 exponential negative 600t, then plus 73 72 80 exponential negative 2400t. So that's the derivative. So upon doing that, we will divide each and everything by 46080, and it will be 12.5 12.5 when we've brought 57, 60, 100 exponential negative 1500t into this other side for all of the subjects inside this particular equation to be positive. So upon bringing that, then dividing by 46, 080, so we'll be having 12.5 exponential negative 1500t is equals to exponential negative 600t plus 16 exponential negative 2400t. Dividing by exponential negative 2400t, we'll be having 12.5 exponential 900t, which is equals to exponential 1800t plus 16. When we use our calculator, we'll key in those values of 12.5, then exponential 900t, t will be replaced by x is equals to exponential, that's exponential, so it will be exponential 1800t, then plus 16, then calculate. Upon calculation, let's wait for the calculator to process it. So we can see that x at this particular point, you can see that x is 4.110514 times 10 raised to power negative 4. So from the calculator, we'll be having x is equals to 4.110514, and remember x is t, so we can say that this t, let's avoid using the x because there's no anything that will have been initialized by x, so times 10 raised to the power of negative 4, but that's seconds, but we can also write it as 411.05 microseconds, this being the final answer, as power is maximum. So that's the final answer when power is maximum, the instance of time when power is maximum. So then the next equation, we've been told that that's equation E, the maximum power. So finding the maximum power, and the equation of power, we had the equation of power to be this, and so in each and every equation of power we will be multiplying it by this. So at power maximum is equals to, so this is the instance of time. So in this particular equation, we will be replacing t with 411.05 microseconds. So under replacing, let's now put it together. So it will be 384 exponential negative 1500 times amps, that's the instance of time, minus 76.8 exponential negative 600 times amps, then minus 307.2 exponential negative 2400 amps multiplied by amps. The answer is 32.719. That is, we can say that. So the power is equals to 32.72 watts, and that's the final answer of E. Then we've been told that the instance of time when the stored energy is maximum. So the instance of time when the stored energy is maximum. First of all, let's get the equation. Let's get the equation of energy, and you know that for energy, W is equals to integral of P dt, and upon that sorry, we can by integrating power, this being the equation of power, so we want to integrate this, and through integration we will be having 384 divided by this, and so on and so forth. So power, so W is equals to, the equation of W is equals to negative 0.256 exponential negative 1500t plus 0.128 exponential negative 600t plus 0.128 exponential negative 2400t. So we've integrated power so that we can get the energy. So after this, then we all know that in graphical analysis, let me just check if at all I have a script like that. In graphical analysis, we know that when voltage is 0, then at that particular instance of time, the energy is maximum in an inductor. So let's check this. I've been able to get a script, just a summary of those particular graphical analysis. So you can see that there is a current, this voltage, this power, this energy. You can check that from this particular point, when voltage is 0 at this particular instance of time, then in this particular graphical analysis, the W maximum, that's energy maximum, is also maximum at that particular instance when voltage is 0. So from the first questions that we've done, we were given from the question from the letter B, that's the second concept that we had already done. We found the value of time, the instance of time when V is equals to 0. Checking back on that, let me now put that down. Checking back on that, you can see that we found that T. Let me just put it here. Checking back on that, we found that when V at V is equals to 0, then time is equals to 1.54. So that particular time, the instance of time, because we were told that from F, the instance of time when the stored energy is maximum. So at this particular instance of time is also equal to 1.54 milliseconds. So 1.54 milliseconds, so that will be the instance of time. So T is equals to 1.54 milliseconds. So to find the total energy stored, the maximum energy stored, not the total but the maximum energy stored in the inductor, we will be replacing T with 1.54 milliseconds, whereby W is equals to, now when we replace T with that, then the total energy, the maximum energy, not total but maximum energy, will be 0.02857 joules, whereby we can also write it out when we multiply by 1000, it will be 1, 2, 3, so it will be 28.57 millijoules, and that is the final answer of the maximum energy. Thank you, and we'll keep in touch. Have a good day.